So earlier I told you that we cannot compare two movie objects like this. Now, similarly, we cannot write a movie object to the standard output string. The reason for this is because none of these operators are implemented for movie objects. They're only implemented for basic types like integers, characters, floats, and so on. So in this lesson, I'm going to show you how to implement these operators for our movie objects. This concept is called operator overloading. So just like we can overload our functions by creating different versions of them with different parameters, we can also overload these operators. Each of these operators is essentially a function. Let me show you. So let's go back to our movie structure. So let's change the name of this method to operator followed by double equal signs. So this is the implementation of the equality operator for comparing movie objects. Now we have a little warning here from CLion. The warning says that this method can be made constant. What is this about? Well, earlier we made this parameter constant. So now we cannot change any of the members of this movie object. So if we set movie.title to some value, we get a compilation error, right? However, we can still change the members of the current object. So in this object or in this structure, we have access to these members. That is why over here, we're comparing the title of the current object with the title of the other movie object, right? So with our current implementation, we can still change the title of the current object, the current movie. This is not what we want. So the warning is saying you should make this method constant so the current object is not accidentally modified as part of this comparison. And to do that, we have to type the constant keyword at the end of the method declaration. Now with this change, we cannot set the title of the current object to something else. Again, we get a compilation error, okay? Now with this implementation, we go back to our main function. Now instead of the equals method, we can easily compare two movie objects like any other basic built-in types. So now if you run, we can see these two movies are equal. Great. Now there is another way to implement the equality operator, and that is the approach that I personally prefer. We can implement this outside of our structure. So let's grab this code, cut it, and then move it outside of this structure. Now here we have to make a few changes. Previously we had only a single parameter because this function was part of the movie structure. So there we had access to these members, title, release date, and so on. But now that we have taken this function and put it outside of our movie structure, we need to know about two movies, movie A and movie B. So we need to add another parameter here, constant movie, and we're going to make this a reference parameter as well. Now we can call this first and then rename the other one to second. So let's rename this to second. That's good. Now over here, we need to compare the members of first with the second. So let's do that real quick. I'm going to prefix all of these with first dot. Okay. Now, because we have declared both these parameters as constant, it doesn't make sense to make this method constant anymore. That is why we have a compilation error here. So let's remove this. Now, this is another way to implement the equality operator. Now, why do I prefer this approach? For two reasons. The first reason is that some operators, like the stream insertion operator, can only be implemented outside of a structure. So I prefer this approach because this way we can consistently implement all of our operators outside of our structures. The second reason I prefer this approach is because the signature of these functions are more straightforward. So now it's obvious that we are comparing two movies, first and second, and we get a Boolean in return. Previously, when this function was part of our movie structure, it wasn't quite obvious that we are comparing two movie objects. So this is how we can implement the equality operator. Now, with this implementation, it's obvious that we have overloaded the equality operator because this is a new implementation that takes two movie objects instead of, let's say, two integers or two floats, okay? Now, using this technique, we can overload any operators in C++. For example, we can implement the addition operator to add two movies together. It doesn't really make sense here, but if we had 2 point objects, perhaps we could add them together to get a new point. Now, depending on the type of operator we are overloading, the signature of this function varies. So whenever you need to overload an operator, first Google C++ operator overloading. On this page on cppreference.com, you can see examples of various operators. Now, there is a lot of detail here. Have a look at restrictions. But let's look at a couple of examples. So here we have stream extraction and insertion operators. Now over here, it says these operators must be implemented as non-members. That is what I was talking about. So we cannot implement these inside a structure, okay? Now we're going to implement this in a moment, so don't worry about this syntax. Now further down, we have other examples. So we can also implement the increment and decrement operators if it makes sense. So look at this page for examples of overloading operators. Now let's implement the stream insertion operator. So for this operator, we're going to define a function that returns an object of type OStream. OStream is short for output stream. Now we're going to return this as a reference for performance reasons. The name of the function is operator followed by 2 left angle brackets. Now here we need 2 parameters. The first parameter is another OStream, again as a reference. We call it stream or whatever. The second parameter is a movie object, again as a reference for performance reasons. So this operator or this function takes a movie, writes it to a stream, and returns a new stream. Here's how this is going to work. So we have access to this stream. This could be our standard output stream like cout. So at runtime, depending on where we use this operator, this stream is going to be different. What I mean here is that if we use this operator with the standard output stream, then this stream object is going to be cout. But we can use this operator with files. We're going to talk about that in the next section. So using the same implementation, we can write a movie object to a file, okay? So OStream is just an abstraction for an output stream. The type of the output stream will be based on where we use this operator, okay? So here we have a stream. Now, how are we going to write this movie to this stream? Do we want to write only the title or all of its members? Here's an example. We can just write the title, okay? Now, at the end, we have to return this stream object. Now, the reason we have to return this stream is so that we can chain the stream insertion operators, okay? So here's our implementation of this operator. Now we can go back to our main function and test this. So let's write movie1 to the standard output stream. Take a look. Here's what we get. Now we could enhance this, and instead of writing just the title to the output stream, we could write all the attributes or all the members of this movie object, okay? Now one last thing before we finish this lesson. Again, in this example, we don't want to change this movie object. So to prevent any accidental changes, we should make this parameter a constant. Now, as your exercise, I want you to define a structure for representing a point. Each point should have X and Y coordinates. Then overload the equality and stream insertion operators for points. All right, let's define a new structure called point with 2 members, X and Y. Next, we're going to implement the equality operator. Now for this, we're going to take 2 points, like point A and point B, and then we need to return a Boolean. So we can guess the signature of this function without looking at a reference. So we're going to define a function that returns a Boolean, and we're going to give it 2 parameters. We can call them first and second. Now, because this function is not supposed to make any changes to this point objects, it's better to declare them as constant. Good. Also, for performance reasons, we can make them reference parameters. Okay, good. Now here we're going to return a Boolean expression. First.x should be equal to second.x, and first.y should be equal to second.y. As simple as that. Let's test our implementation. So we're going to create 2 point objects. We can call them X and Y. And then we're going to print the result of this expression. Now here we get a compilation error because the stream insertion operator has a higher priority. So the compiler is going to evaluate this expression first, and then it doesn't know what to do with the rest. So to force the compiler to evaluate this piece of code first, we have to wrap this in parentheses. So now, if we run the program, we see 1 because our points are equal. But if we make any changes here, now we get 0 or false. Good. Let's move on to the next part. We're going to implement the stream insertion operator. So this operator is going to take a stream at a point and return a stream. The reason we return a stream is so we can chain the stream insertion operator. So the return type is oStream as a reference. Here we're going to give it 2 parameters, oStream as a reference, and a constant point as a reference as well. Now we're going to take the stream and write something like this to it. Point.x, then a comma, and finally point.y. You know what? It's actually nicer to wrap them in parentheses. That is how we show points in math, right? So let's do that. And finally, we return the string. Now we can also combine these 2 lines and put the return keyword right here, because the result of this entire expression is an output string. Okay, so let's test our implementation. We're going to write x on the console. Take a look. We get 1 and 2. Beautiful.